Good morning, students. Today we are going to see the topic of optical isomerism. So, when a plane polarized light is passed through the solution of certain complex compounds, they rotate the plane of polarized light. Such a complex compounds are said to be optically active in nature. Optically active complex can exist in following form, that is the isomer which rotate plane polarized light towards left, that is in anti-clockwise direction, is called as levorotatory form or L form. The isomer which rotates the plane polarized light towards right, that is clockwise direction, is called dextrorotatory or D form. The isomer which does not rotate the plane polarized light is called mesoform. Now, these are the two important conditions for optical isomerism. The molecule should be asymmetric in nature, that is, they should not have plane of symmetry. The molecule should not be superimposable on its mirror image. So, first topic is optical isomerism in tetrahedral complexes. So, tetrahedral complexes Ma by 4, Ma2b2 and Ma3b type do not show optical isomerism. Now, tetrahedral complexes of MABCD type show optical isomerism because all four ligands are different. So, we are going to see the example of this complex. So, just see in this complex, here AS is attached to 4 different ligands. So, this is the D form of your this complex. When we write its mirror image, the position of your ethyl group is shifted towards left and position of CH3 group shifted towards right. This is the L form of your this complex. This complex does not have any plane of symmetry. That's why it shows optical isomerism. Optical isomerism in square planar complexes. As we know that square planar complex possess plane of symmetry or axis of symmetry. That's why these complexes are optically inactive. It is important. It is asked for a short question of 1 mark in the exam. Now we are going to see optical isomerism in octahedral complexes. So, octahedral complexes of type Ma6, Ma5b, Ma by 4b2, Ma by 3b3, Ma4bc do not show optical isomerism due to the presence of symmetry. Octahedral complexes of type Ma2b2c2 show optical isomerism. So, this is the example of this type of complex. So, just see in this complex, it is the cis isomer because fluorine atom is present at 5 and 6 position. Similar ligand present at 5 and 6 position as well as 1 and 2 position as well as 3 and 6 position. So, just see, this is the cis form of your complex and its rotate plane polarized light toward clockwise rotation. That's why it is D form. Draw the mirror in front of this complex. and draw L form of this complex. So while writing L form of this complex, obviously position of this 2 chlorine shifted towards right, and your right hand side ligand shifted towards left hand side. It is also a cis form of compound, but it is L form. It is cis D form. It is cis L form. Student should not confuse with cis, because cis is obtained from geometrical isomerism phenomena. D and L obtained from optical isomerism phenomena. So now we are going to see octahedral complexes of M, A, B, C, D, E of type. This is the complex of this type. It have 15 geometrical isomer and 30 optical isomer. So we are going to see one pair of optical isomer of this type. So just see, all ligands are different. This form in which your nitro, it should be nitro, and amine when present in 2 and 3rd position, this form is D form. Now when place the mirror in front of it and we obtain its mirror image, which is known as L isomer of this. Now we are going to see octahedral complexes of the type Ma by 3, where A is bidentate ligand. So example of this type is CON by 3 plus ion. So just see, this is the D form of this complex. So in a D form, one of your ethylene diamine ligand is present on left hand side. When we place a mirror in front of it, this left hand side, obviously this ligand which are present on left hand side, it is shown in on right hand side. So this is the D form and it is the L form of your this complex. Now we are going to see octahedral complexes of the type AA by 2 A2. This is the example of this type. Now just see, similar ligands are present at 2 and 3 position. That's why it is cis geometrical isomer. See, this cis geometrical isomer rotate plane polarized light toward right side. That's why it is D isomer. We draw mirror image of it, which is cis L isomer of it. It also have, this compound also have a mesoform, which is like this. Just see, your both chlorine is present at 1 and 6 position. That's why it is a transgeometrical isomer of this compound. Beside that, it possesses plane of symmetry. I pass a line like this, it exactly cut into 2 equal half. That's why it is mesoform and it is optically inactive in nature. Now we are going to see complexes of the type A by 2 B2 type. This is the example of this type of complex. This complex have 2 geometrical isomer, that is cis and trans, and 3 optical isomer, that is D, L and mesoform. So just see in this arrangement, your chlorine is present at 6 and 4 position. At 5th and 6th position, ammonia ligand is present. That's why it is cis geometrical isomer. Since it rotates plane polarized light towards right hand side, that's why it is D isomer. Just draw the mirror image of it. So this isomer is also cis isomer, because in this case your amine is present at 1 and 2 position and chloride is present at 3 and 4 position. That's why it is cis geometrical isomer. It rotates plane polarized light towards left hand side. That's why it is L form. There is also one arrangement of this this compound is possible, which is written here. Just see your amine written at 1 and 6 position. That's why it is trans-geometrical isomer. If I pass plane of symmetry from here, it cuts this compound into 2 equal half. That's why it is mesoisomer, and it is optically inactive. Octahedral complexes of type MAB by 3. CR Glycinato by 3. It is the example of this type of complex. This complex have 2 geometrical isomers, that is cis and trans, and it complex have 4 optical isomers. One pair is shown by cis form, another pair is shown by trans form. So now we are going to see geometrical as well as optical isomer of your MAB by 3 type of complex. So just see in this arrangement of complex, you are at 1 position and 6 position, same donor atom is present, that is oxygen. Also at 2 and 5 position, same donor atom is present. That's why it is the transform trans-geometrical isomer of this compound. This geometrical isomer basically rotate plane polarized light towards right hand side. That's why it is D form, D optical isomer form of your this complex. That's why it is simply written as trans D L isomer. When we put mirror in front of it, we got trans L isomer, which is written like this. Now just see in this arrangement, same donor atom are present at 1-2 position. That's why it is known as also at 3 and 4 position. That's why it is known as cis geometrical isomer, since it rotates plane polarized light towards right hand side. That's why it is the D optical isomer of this compound. When we put mirror in front of it, we can easily draw its L isomer form. So basically this compound have 2 geometrical isomer, and each geometrical isomer give a pair of optical isomer like this. Complexes containing hexadentate ligands are also optically active. So in next class we are going to study oxidation and reduction topic. Thank you very much.